Hello everyone, this is Rudrani and I'm going to explain to you pointer arithmetics in C++. We can perform arithmetic operations on pointer variable just like you do it on a numerical value. जिस तरह हम एक न्यूमेरिकल वैल्यू को ऐड सब्ट्रैक्ट करते हैं उसी तरह हम पॉइंटर को भी कोई वैल्यू ऐड या सब्ट्रैक्ट कर सकते हैं. We have few operations which we can perform on pointers which we will discuss. So when we increment, decrement or add a number or subtract a number from a pointer, that time we are actually changing the memory address pointed by the pointer. Suppose एक pointer variable a को point कर रहा है और उसका address 1000 है. अगर हम उसको increment कर देते हैं तो उसका next value जो हो जाएगा वो 1001 होगा अगर वो character हुआ, वो 1002 होगा अगर वो integer होगा. So we will go to the next position of the pointer. So when we increment or decrement a pointer, we go one step ahead or we go one step back. Similarly, if we add or subtract a number from the pointer, we skip that many places and move forward or backward. These operations work well with arrays because arrays have a contiguous memory allocation. Contiguous का मतलब होता है one after another. That means सपोज एक एरे में 10 आइटम्स प्रेजेंट है तो वो 10 आइटम्स वन आफ्टर अनदर प्रेजेंट है. दैट मीन्स देयर इज नो स्पेस इन बिटवीन. वी हैवंट स्किप्ड एनी एलिमेंट. We are placing it one after another, so location wise it is placed one after another. We prefer using a pointer in our program to access an array because the variable pointer can be incremented unlike the array name which cannot be incremented. हाँ, अगर हम डायरेक्टली array कि नेम से उसे इंक्रीमेंट करें तो वो पॉसिबल नहीं है क्योंकि हम एरे के नेम को तो इंक्रीमेंट कर नहीं सकते. तो इसीलिए हम उसे एक पॉइंटर असाइन करते हैं ताकि हम एक ही पॉइंटर के थ्रू डिफरेंट एरे एलिमेंट्स को एक्सेस कर पाए यूजिंग द सेम पॉइंटर. Either by incrementing or by decrementing, we move or come back to the next position. So let's discuss the concept of base address first. A pointer holds the address of the very first byte of memory location where it is pointing to. This first byte is known as the base address. That means जहाँ से हमारा array start कर रहा है उस location, जो भी location को point कर रहा है, that location का address is our base address. For example, when the base address of an integer array is 1000, the next integer is present at address 1002 because the size of one integer is 2 bytes. That means when a base address of an integer array is 1000, the next integer is present at address 1002. This is because the size of an integer value or integer variable is 2 bytes. So agar first element is at 1000, the second element will be a 1000 plus 2, that is 1002. That is the reason the next integer is at 1002. Similarly, अगर हमारा ये character array होता जिसका base value 1000 है, तो next integer would be at 1000 plus 1 because size of a character variable is 1. So next element would be at 1000 plus 1, that is 1001. So let's come to valid pointer arithmetic operations. So valid arithmetic operations that we can do on a pointer are, first is we can add a number to a pointer. Second is we can subtract a number from a pointer. We can increment a pointer. That means we can add 1 to the pointer. We can decrement a pointer. That means we can take away 1 from the pointer. We can reduce it by 1. We can subtract 2 pointers. That means if there are 2 pointers, P1 and P2, pointing at variable A and B, suppose, then we can subtract P1 from P2 or we can subtract P2 from P1. And we can of course compare 2 pointers. Just to check which one is greater or lesser, we do it to compare various elements of an array. So what are the invalid pointer arithmetic operations? We cannot add. We cannot add 2 pointers. This is not possible. We cannot divide 2 pointers. This is also not possible. We cannot multiply 2 pointers. So this is not possible. The only thing we can do with 2 pointers is we can subtract 2 pointers. You must note this. Otherwise, we can add or subtract numbers from a pointer. We can increment or decrement a pointer. But when it comes to operation with two pointers, we can only subtract. So what is incrementing a pointer? If PTR is an integer pointer which points to memory location 5000 and size of an integer variable is 16-bit. 16-bit means 16 by 8, size of byte is 8. So 16 by 8 is equal to 2 bytes. When we increment it, incrementation means PTR plus 1. When we increment it, it will point to the next memory location. And what is next memory location? Next memory location is 5000, which is base address plus size of data type of the variable, that is 2, because integer size is 2. So next address is at 5002. The rule to increment the pointer, which I have discussed, is new address is equal to current address. Current address means base address. The starting point here is 5000. So current address is 5000, followed by size of pointer data type. So pointer data type means integer. Size of integer is 2. So next address is 5002. Now let's see this through a diagrammatic representation. If we increment a pointer by 1, the pointer will start pointing to the immediate next location. That means if pointer is at P, the next address will be P plus 1. We have taken an integer pointer P and an integer array of 5 elements ARR. We have assigned the value of ARR to P. Note, we do not use ampersand or address of operator while assigning the value of array, because the array name represents the base address or it represents the first element of the array. So automatically when we assign ARR, we are assigning an address. So we don't have to specifically mention ampersand. This is not required. If current address of pointer P is 1000, then pointer plus plus statement will increase it to 1002 and not 1001. Why? Because we have discussed it increments by the size of data type of the pointer. Since size of integer array is 2, first address will be at 1000, second address is at 1002. Array will be moving from one step to another step only because we are traversing the array from element 0 to element 1 to element 2 and so on we go on. But in case of memory location and allocation, we are incrementing, when we increment by 1, we are incrementing 2 spaces each time. Similarly, if it is a character array and we have taken a character pointer C and assigned the address of character array to character pointer, then when first location is at 100, second location will be 101. Why? Because size of character is 1 only. So we will be incrementing 1 by 1. That means in case of integers, we'll be incrementing by 2. In case of double, we'll be incrementing by 4 and so on. Similarly, when we will be decrementing the pointer, that means we will be going a step back. We will be reducing the pointer by 1. That time, we follow the same rule. If the base address or the first location is at 5000, then size of the previous element will be base address minus the value of the pointer data type. This is the formula. So PTR minus minus means what? It means the same as base address, that is 5000, minus size of data type of the pointer, that is 2. So what is the next? What is the previous address? The previous address is 4998. So when we decrement the pointer, we get the value 4998 in case of an integer. Had this been a character array, then it would have been 4999. Similarly, we can add numbers to pointers. Adding a number n to a pointer leads the pointer to a new location after skipping n times size of the data type. We can understand it better through this formula. That means when a number n is added to pointer PTR, the next address starts from pointer's address, that is the base address, plus n, which is the number, multiplied by size of the data type of the pointer. So, for example, in case of an integer, when PTR will point to a 2-byte integer which has its base location at position 5000, then if we have to traverse 5 places ahead, that is n is 5, then the address at the 5th location from the starting point will be 5000 plus 2 into 5, that is 5010. So it will point to the memory address 5010. मतलब जब हमारी स्टार्टिंग पॉइंट 5000 है और हमें 5 प्लेसेस अहेड जाना है, हमने जब पीटीआर प्लस 5 किया है तो हम नेक्स्ट एड्रेस में जाने के लिए हमें 5000 प्लस ट्वाइस इंटू 5, तब 5000 प्लस size of data type into number of steps we want to move ahead is equal to 5010. तो हमारा final location हो जाएगा 5010. Similarly, we can also subtract numbers from pointers. Subtracting a number n to a pointer leads the pointer to a new location which is previous n times the size of the data type from the current location. So this is the formula: PTR minus n is equal to PTR minus n into size of whatever data type of the pointer it is. That means in case of an integer, if we have to move n steps ahead, then it will be n into 2. So if PTR is a 8-byte double pointer whose initial location is at 5000, then PTR minus 5 is equal to 5000 minus data type size, that is 8, into 5, which is n. So the answer we get is 4960. मतलब जब हमने एक 8-byte पॉइंटर लिया है जिसका इनिशियल लोकेशन 5000 है और हमें 5 स्टेप्स अहेड जाना है, तो हम 5000 minus 8 into 5, because 8 is the size of the data type, double, and 5 refers to the number n. That is the number of times we want to go behind. So our answer is 4960. We can also subtract two pointers. The difference between two pointer indicates how apart or how far the two pointers are from each other. It gives the total number of elements between the two pointers. That means if you have two pointers at two separate locations, by subtracting one from the another one, we get to know how far, how ahead or how behind, how far each address is from each other. The formula we use is address held by the second pointer minus address held by the first pointer divided by size of data type. For example, when size of integer is 4 bytes. Now integer double, they have different values on different compilers. Like on Turbo C++, the value is 2 bytes. Similarly, on some other compiler, it can be 4 bytes also. So if an integer is of 4 bytes, if integer pointer ptr1 points at memory location 10,000 and integer pointer p2 points at memory location 10,008, then result of ptr2 minus ptr1 will give us 10,008 minus 10,000 divided by size of integer, which is 4. So the answer will be 8 by 4 is equal to 2. That means both the pointers ptr1 and ptr2 are 2 steps far from each other. मतलब अगर हम इंटीजर लेते हैं जिसका साइज 4 बाइट्स है, कंपाइलर टू कंपाइलर साइज ऑफ इंटीजर वेरी करता है, कुछ में 2 है, कुछ में 4 है. लाइक टर्बो C++ में it is 2 and on code blocks it is 4. तो जब ptr1 पॉइंट कर रहा है 10,000 पे और ptr2 पॉइंट कर रहा है 10,008 पे, जब दोनों को हम सब्ट्रैक्ट करते हैं उसका वैल्यू हो जाएगा 10,008 minus 10,000 divided by size of the integer or size of the data type जिसका आंसर है 2. Let's take an example. Here we have taken two integer variables a and b with value 10 and 20. We have taken two pointers ptr and ptr1. We have assigned the address of a to ptr and address of b to ptr1. Here we are trying to subtract ptr1 from ptr. So when we run this program, we will be getting output 1. Why? Because size of integer we know is what? 2. So when we subtract 2000 from 2002, we actually divide this entire thing by the size of the data type, which is 2 because it is an integer, and then we get the value what? 2 by 2, which means it is 1. Hence, our output is also 1. So this is how we do subtraction of two pointers. This example will show you how we can traverse different elements of an array by incrementing the pointer. In the first case, we have taken an array and we are not using pointers. It is a normal simple array. We have declared an array of 5 elements and we have used the loop variable, that is I, for incrementation purpose. So if we have to print the array elements, what do? We will initialize I with 0. I should run for 5 times because there are 5 elements. We will print what? We will print the array element at ith position, and then we get the values 1, 2, 3, 4 and 5. So if we have to achieve the same thing using pointers, what can we do? We can assign a pointer with the address of array. Address of array means the position of the first element of the array. So we are not assigning the ampersand sign. We take a loop variable I and we are trying to print the array elements. So we start the for loop. We print p plus I. We have discussed in the introductory video also that array at position I is same as pointer plus 1 position. Array at I is same as pointer plus I. In the first case, we get pointer at position 0. In the second scenario, we increment I by 1. We know P is pointing at the first location. So when we increment pointer by 1, it points to the second memory location. So we get the output 2. Similarly, again, when we increment I, P increments by I, that is 1, and it points to the third memory location. Again, we increment by I, P increments by 1, it points to the fourth memory location. We get the value 4. And similarly, when we increment I again, we will be getting P at next position, that is 5. Thus, the output here will also be the same. It is also possible to compare two pointers. A pointer comparison is valid when both are of same type, which means when both are of integer type or both are of double type or when both are of character type. We cannot compare two pointers which have different data type. For example, we cannot compare char and int together. We cannot compare double and int together. We have to make sure that the pointers are same. All relational operators can be used for comparing pointers of the same type. So we know what are relational types: greater than, less than, greater than equal to, less than equal to, double equals, equals, and not equal. So we know what relational operators are. This is the basic fundamentals of computers. So everyone knows what relational operators are. We can use all the relational operators with pointers for comparison. So in this example, we'll be comparing two pointers. We have taken two integers I and j. We have taken two integer pointers, ptr1 and ptr2. We have assigned the address of I in ptr1 and address of j in ptr2. So we'll be comparing both of them using greater than. We can use any of the relational operators. This is a simple program to see which one is ahead. So if ptr2 is greater than ptr1, then we get the output ptr2 is ahead from ptr1, else we'll be printing ptr1 is ahead from ptr2. So the output in this case, as ptr1 is ahead from ptr2, we will be getting the output PTR1 is ahead from PTR2. While we're incrementing or decrementing a pointer, it is important to make sure that we know which location we are assigning the dereferencing operator. Both increment and dereferencing operator have equal precedence. Same goes for decrement operator. And associativity is from right to left. That is, expression is evaluated from right to left. Both are unary, that means there is only one single operand. We don't require two separate operands, we don't require two separate variables, we require just one variable. The operation is performed on one variable. As we know, associativity is from right to left. That is, we go from right to left in this following example. First, this is evaluated and then this is evaluated. That means first the PTR is incremented. That means if PTR is at 100, it will first increment to 101 and then we'll be assigning the dereferencing operator. So element at 101th position will be pointed through the pointer. Whereas in this case, first the dereferencing operator is to be evaluated. So in the same example, if element is at 100 position, first we make sure we point to the 100 location and then we increment it. So then we increment it and then it points to 101th position. Though in most cases you will get similar output, but we must understand how to evaluate the expression. So always remember, we always start evaluating from right and then we go to left. Thank you. In the next PPT, we'll be discussing about dynamic memory allocation, static memory allocation, and C++ memory maps.